2x4 testing for impact is defined by this ASTM E1996. A couple weeks ago, Matt and Stewart came to me asking about how this applies to like Florida product approvals and how we get around frames that are taller than what's in the approvals from Florida or like Texas's TDI. So we started kind of looking into this, and just as kind of a summary of what's in here, this standard defines the different 2x4 sizes and weights that those windows have to be tested to. So there's missile levels A through E, different weights, different speeds that they launch out of that cannon. Kyle was going to show and send a video for. And then based on your wind speed from the map, that defines which missile level from the chart you have to test to. So some areas only have to hit a steel ball, small 2x4, all the way up to E that's like right on the coast, which is a big 2x4 doing like 50 miles an hour. So to get around the fact some frames aren't approved, what we've done is put together a spreadsheet based on this table with the weights and speeds that are required. So we can plug in the allowable moment for the mullion that you'll get out of our design sheets. And then based on our speed, you'll pick your required missile size of 2x4. And the sheet will essentially tell you whether or not the mullion you plugged in is good or not for that weight of 2x4, that speed of 2x4, based on the impact energy you come up with. So this is something that's going to have to start going into all of the impact jobs that don't have a Florida approval, or if we're taller than the Florida approval. If I remember right, if that's what we decided on, Stuart.
Yes.
So it'll be another just kind of front end page, kind of like some of the seismic sheets, just to say, hey, this is okay. We're basically ignoring having to check it because of this.
So what happens if nothing works? We're over the limit, and our bending capacity that we're saying it needs to do exceeds the impact energy, or doesn't exceed the impact energy.
You're going to have to kick it back and say, hey, we need testing or a product approval to show that this actually works. Because usually when we're starting to get into having to look at this, it's already because the frame size is outside of what Florida has approved based on testing, or what TDI has approved based on testing. So if for whatever reason it appears that this doesn't work, then it's getting really sketchy that it probably wouldn't pass testing, and there's probably a reason it wasn't included in testing. If that makes sense. So there is a drop down on here to switch between the different ASCEs for 710 and 716 to account for the different wind speeds. So like 710 does 130 through 150. Oops. And then 705, that actually backs down to the service speeds. So that's another thing you got to make sure you pay attention to.
If for some reason it didn't work, is there any way that you can figure out so that it would work? Like, is there any other variable or consideration?
Not really, because this is already trying to work around the lack of testing. So if this doesn't work, you're stuck with going back to testing it if there's not already an approval.
I'm really worried we're going to lose a lot of jobs doing this.
Well, I actually think that this is a potential to be able to validate a system that needs to be impact rated. And so ultimately where you see the impact energy and the moment that's associated with our mullion, most of the time the impact energy is going to be less than our capacity for a moment on the mullion. And all that this is doing is it's filling in the gap of the unknown. So what if we have a system that is tested for 8 foot, but the architect really wants to go to 10 foot? how do we justify that engineering wise? We can basically understand and know that the glass may be able to handle the impact, but how do we know that a mullion can handle a direct impact of a load of a 2x4? That's the question that we have to ask and be able to justify, with engineering data or testing. And so I don't think that this is going to be a limiting item in terms of mullions, because mullions are usually built pretty strong whenever they're impact rated systems.
Yeah,
I think that they have reserve energy to be able to handle the immediate energy of the impact.
This is really just covering a gap in the calcs that on a lot of Florida jobs I had just been kind of based on intuition saying, okay, yeah, the 2x4 impact, if it's directly on the frame, is going to be okay, because we had been looking at are the DLO sizes within the product approval. But then if the frame was taller, if the vertical was, say, tested for 10 feet, but we're going to 12, there was nothing to justify that 12-foot mullion was good for impact, that we were already designing for wind. This is basically saying now that, yes, that mullion is okay, instead of just kind of assuming that, yeah, the 2x4 impact is less than our wind load. So it's really nothing in the end should change unless you're in this zone, this level E, which I don't think we've ever really seen. I know I've been asked about it once by Chad at Synergy, but I don't think that ever went anywhere.
And this spreadsheet is assuming like the mullion's not even seeing wind load, it's only seeing the impact load, basically.
Yeah,
Okay.
Basically.
Yeah, I don't know if there's
It's like an either or type of.
Yeah, I don't know if there's a load case that would say you've got to combine the two.
Well, in the testing, it's not under load at the same time that it's being, fired upon. So.
Yeah, that's what I was just going to say. The testing assumes that they're separate. So.
Okay.
So in the event our mullion bending capacity is less than our impact energy, and we go to our clients and say, hey, this isn't going to work, it has to be tested. Testing is not really something our clients can do or are willing to do. So what do you do on a project like that? Because they're not going to come back to us, potentially.
If you run into a situation like that, it's going to be extremely likely it doesn't work for wind either. So if you're in a situation like that, they're doing something extremely weird for a hurricane zone. Because
I don't think that this is as limiting as what you're thinking of it, Kyle. I think that the mullions would typically have enough reserve energy because it's an impact rated system. It's stiffer than the regular types of systems, and so I think that it's probably going to be okay unless we're in a missile level E, and those usually only happen down in Miami-Dade counties.
But let me ask you this: if you're saying, am I hearing that you're saying most of the time it'll probably be okay? If that's the case, are we spending extra time to do an exercise when most of the time it's okay?
Well, I think that that's been a gap in our calculations to where we have no idea if it is okay or not, and we're just saying, okay, this is outside of the testing requirements. It's outside of what the Florida Building Code is allowing. How do we justify this with engineering calculations?
It was a liability before because we were making assumptions. Now we're proving the assumption. So
it's at least some proof of the assumption that we're trying to make.
Yeah, going back to what Kyle was saying about whether or not this will work or not, just as an example, if you got, say, 30 PSF, which is fairly typical for a lot of hurricane zones we see, it's even on the low side sometimes. If you've got 10-foot high frame, 4-foot trib width, you're looking at 1,500 foot-pounds. So if your mullion works for that wind load, you're even good for missile E for a 705 job, just automatically, because you're designing for a higher wind load than what's required for impact. So you're going to have to be in a really weird situation for wind load to be lower than what's required by impact for a lot of cases.
What this does is it buttresses our position that the system is good for impact, because somebody could, in their review, say, hey, you're outside of the tested limits with this system. How are you justifying that this is good for impact? And so this basically allows us to say that it's good for the impact, basically because we've looked at it with engineering knowledge.
So what happens if you have a part that hasn't been tested? For instance, I mean, for this example, we're looking at the 451TCG001. Let's say it's the 451CG113, the heaviest of that system. I've never seen that in a testing report, you know, as being in the mock-up that's physically tested. So yes, it's going to work because it's stronger, but if it's not actually been tested in apparatus, is it fair to make this comparison on paper? Because it hasn't ever been tested.